All right, what can we do with a cosecant? So cosecant is related to the sine. So remember that the cosecant is 1 over the sine. Oops, wrong letters. So the cosecant of pi over 2 minus t is equal to 1 over the sine of pi over 2 minus t. So let's clean this up and see what we get. So that's going to be 1 over the sine angle difference formula. That's going to give me sine of pi over 2 cosine of t. Sine gets the sine SIGN right, so then we go cosine pi over 2 sine of t. And then we clean this up. All right, let's see, what do we got? Sine of pi over 2, so thinking about unit circle, pi over 2 is up here, the y value is 1, sorry, the x, the y and x value is 0. All right, so sine is 1, cosine is 0, so this becomes 1 over 1 cosine of t. And then this whole thing is 0, it's gone. And so that means we get here the secant of t. And my hope is now that we stop to look at this for a minute, this should look familiar. Why? This pi over 2 is like 90 degrees. And what this is right here is actually the cofunction identity I want to remind you of. So cofunctions. Right, notice secant versus cosecant. And the way cofunctions work are as follows. Here we have a right triangle. If I claim this angle is t right there, then this angle in radians has to be pi over 2 minus t. Right? If we did that same thing in degrees, 90-degree angle here, pi over 2. If this angle is t, this would be 90 minus t. And what happens there is the opposite and adjacent sides switch places. So that means sine and cosine switch places. Secant and cosecant switch places. Tangent and cotangent switch places. And that's this pi over 2 minus the variable is always going to switch to the cofunction. So if somebody told me they had the tangent of pi over 2 minus t, that's going to have to be equal to the cotangent of just t. Switching sides of the triangle switches to the cofunction. The tangent's cofunction is cotangent. The cotangent's cofunction is tangent. Right? So another cute version of that.